Hey guys, so today we're going to be talking about gradient or slope as part of coordinate geometry and linear relationships. By the end of this video, you should be able to calculate the gradient of any straight line by using either the gradient formula or rise over run or y equals mx plus b. So what is gradient? Well, gradient, we also call it the slope sometimes, or the steepness of a straight line. You can kind of think of it as a road. So is a road going uphill? Is a road flat? Or is it going downhill? So gradient can be going uphill, and we read from left to right. So for example, this example down here, if I read from left to right, this gradient is going from left to right up. It's going uphill. And this will have a positive number value. But if the gradient is going downhill from left to right it's going down, then it will have a negative value. And if it's a flat, it'll have a zero value. Now, the higher the gradient, meaning the bigger the number, the steeper the line. So the steeper this line will get closer to the y-axis. We represent the gradient using the small m because we use the big M for midpoint. And you can also see this small m when you have y equals mx plus b. That small m in the gradient intercept form of a straight line is actually the gradient. Now there's two main ways to find gradient. The first way is rise over run, and the second way is a formula. So if you're familiar with how to find distance and midpoint, then you'll understand what y2 and y1 is and what x2 and x1 is. And it's the same steps. So let's go through the formula steps first, and then we'll get into rise over run. So the formula steps are the same as midpoint and gradient. Label one of the coordinates x1 and y1, and label the second coordinate x2 and y2. And then you just chuck it into the formula and simplify. And we'll go through a few examples of that next, just to show you what I mean. Let's look at rise over run. Now, both of these are the same thing technically, and they both use Pythagoras' theorem. But for now, you just need to know how to calculate it, and we'll look at its use and application a little bit later on. So rise over run steps are: create a right angled triangle by finding any 2 points that are exactly on a corner. And when I go through the example later on, you'll understand what this means. Once you've made your right angled triangle, then you calculate by how much it rises or how much it goes up or down vertically. Then you calculate by how much it runs or how far it goes horizontally. Then you put it into the rise over run formula and you simplify. Let's go through a few examples, and hopefully those two steps will make sense. Let's start with example 1, where we talk about the steepness of a line. So the steepness of a line is the one that goes the most uphill or downhill. Which one of these is the steepest line? Well, you can clearly see it's line 2. It's the most uphill. Now imagine climbing that. Let's go on to example 2. Example 2 says, use the gradient formula to calculate the gradient. So here it's telling us which method to use. Often in an exam or in questions from the textbook, they won't tell you which method to use. You can use both. Each question will be better to use one or the other, and you'll get the hang of which one to use later on. So this question is actually telling me to use the gradient formula. Now, if you remember the steps are that you have 2 points, A and B in this case, and we label the first one x1 and y1, the first x and the first y, and we label the second one x2 and y2, the second x and the second y. And then you have your gradient formula, and you have to memorize this. y2 minus y1 all over x2 minus x1. So then we substitute in y2 minus y1, 2 minus 6, all over x2 minus x1, 6 minus 3. Now some people like to use colors here. So for example, if I made x1 yellow, I would put that yellow in the formula, change the color. Let's say orange, I make x2 orange and I substitute that in there, and then different colors and so on and so forth, just to avoid silly mistakes. You figure out what works for you, but once you've done this a few times, you'll understand how to do it and it becomes second nature. So if I use the colors, it saves me from making silly mistakes. So once I've chucked it into the formula, I simplify. 2 minus 6 is negative 4, and 6 minus 3 is 3. Now, the gradient can be written as a fraction, as a decimal, or as a whole number. However, we can never round off. So this number here, negative 4 over 3, is a decimal that keeps going. It's not a terminating decimal, and it's not a whole number. So I leave it in fractional form if it is not an integer, which is a whole number, or a terminating decimal. So that's the final answer for the first example. Let's move on to the second example. Again, we're going to use the gradient formula. So we label the first one, first x and first y, and the second one as second x and second y, or x1, y1, x2, y2. Then we substitute it into the formula. However, we have to be very careful here that when we're dealing with negative numbers, we put it in brackets, and I'll show you why. The formula says y2 minus whatever y1 is. So y2 is negative 1, okay, that comes first, minus whatever y1 is. And y1 here is negative 3. So you'll see here it's minus 1 minus 3. And that changes the whole answer if you don't write that properly. Some students will make silly mistakes and say, okay, there's already a minus there, I don't have to put the one that's in the formula. No, it's y2 minus whatever y1 is, whether they're positives or negatives. Now, how does this change everything? Well, we know from directed number that when two symbols are next to each other and they're the same, that becomes a plus. So that actually is minus 1 plus 3, which is 2. And then underneath we have minus 4 plus 6, which is 2 as well. And 2 over 2 is 1. So just be careful of negative numbers there. Let's move on to example C. Example C, again, using the gradient formula, first x and first y, x1 and y1, second x and second y, x2 and y2. Sub it into the formula and simplify. Now here, at the end, I get negative 5 over negative 2, which is actually 5 over 2. And I can write that as 5 over 2, or I can write that as 2.5. It's often easier if you can write it as a decimal or a whole number to write the gradient as a decimal or a whole number. It's easier to interpret, it's easier to grab realistic values from, and it's easier if you have to substitute anything back into the equation of the line. So that's how we use the formula. Let's move on to how we use rise over run. So I'm going to zoom into 3A just so I can show you a little bit easier on the steps and how it works. Now this question says to use rise over run to calculate it. Step 1 is to create a right angle triangle using any 2 points that cross over exactly on a corner. So my line is the green line there that you can see. And this line is pretty cool because it has multiple points which cross over exactly on a corner there. And you can see them all as the black dots. I can use any 2 of those dots. It doesn't matter which ones I use, I'll get the same answer. So to make my life easier so you can see it clearly, I've used the first and the last one, and I made a right angle triangle, as you can see there. So step 1, make a right angle triangle using any 2 points that cross over exactly on the corner of any of the grid lines. Step number 2, see how much it rises or goes up or down vertically. So how many boxes on this right angle does it go up or down by? 1, 2, 3, 4, 5, 6. It rises by 6, and each box is worth 1, so the rise is 6. Where would that change? If each box was worth 2, then the rise would be 12, because there'd be 6 times 2. So we have to look at the value of how much each grid box goes up or down by as well. So the second step was find out how much it rises, and the third step is find out how much it runs or goes horizontally. So how many boxes? 1, 2, 3, 4, 5, 6. It also goes across 6 boxes. Rise over run, 6 over 6, which equals 1. Now here we can see that as we move from left to right, the line is going up. So the gradient is going to be a positive number. Remember, left to right, line goes up, it's a positive number. Let's do example B. Now example B, if I go down the line, I have that point that's exactly on a corner. I keep going down, none of these touching a corner up until there. That touches a corner there. I keep going, there's no other point so far. So there's only 3 points on this line that touch an exact corner. I can use any of those 3 points. I could use this point and make a right angle triangle there, or I could use those 2 there. I've used the first and last just to make it easier for you to see. So I make my right angle triangle and I see how much it rises. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Rise is 10. Run 1, 2, 3, 4, 5, 6, 7, 8. And it runs 8. So remember, rise over run. 10 over 8, which simplifies to 5 over 4, or 1.25. Now here we can see that the line from left to right is going down. As we move from left towards right, the line is going down. And when the line goes down, the gradient is a negative. So the answer is not 5 over 4, it's negative 5 over 4, or negative 1.25. Now that's not rounded off. 5 over 4 is actually 1.25. So it's easier for me to write it as a decimal. However, the fraction is still correct. Hopefully you're understanding rise over run a little bit better now. Let's go on to one of the other ways we can find the gradient. So as we know, y equals mx plus b, the m value is the gradient. So how do I find it if it's not in y equals mx plus b? Well, let's have a look at the first one. Y equals 6x plus 3. This is already in the form of y equals mx plus b. So the m value is 6. And if the m value is 6, the gradient is 6 as well. Let's have a look at example 2. So 4b says 2y equals 6x plus 3. This is not in the form of y equals mx plus b. This is 2y. So how do I get y by itself here? 2 times y. The opposite of 2 times y is divided by 2. And whatever I do on one side, I have to do everything on the other side. So now this becomes y equals 6 divided by 2, which is 3x, plus 3 divided by 2, which is 1.5. So now I have that in y equals mx plus b form. What's the m value here? 3. That means the gradient is 3 as well. Let's move on to 4c. Now this is definitely not in the form of y equals mx plus b. I have my mx value on the side with the y, and I have my b value on the side and the y as well. So the first thing is I have to take my mx value across. So opposite of plus 9x is minus 9x. Whatever I do on one side, I have to do on the other. That cancels that out. So now I'm left with 3y plus 12 equals minus 9x. I still need to get the 12 across. So the opposite of plus 12 is minus 12. Whatever I do on one side, I have to do on the other. So that cancels that out. But y is still not by itself. I still have 3 times y. So the opposite of 3 times y is divided by 3. Whatever I do on one side, I have to do both things on the other side. So now I have y equals negative 3x minus 4. And if you have problems with this question, go back and watch the video on y equals mx plus b and changing the subject of a formula. So here, now I can find my gradient because it's in the form of y equals mx plus b. And the m value is negative 3. Therefore, the gradient of this line is negative 3 as well. So I've shown you 3 ways now of how you can calculate the gradient or slope of a line. I have a few questions here for you to do. Pause the video, try them yourself. If you get stuck, watch the video again to go back up and have a look at the steps that I've done. Make sure you write the steps down and make sure you write the formula. You should have a formula page at the back of your book where you write down all the formulas that you need so you can go back and have a look at them. Okay, you should have finished by now. Hopefully you got them all right. If you didn't, go watch the video again and write some notes down and write the steps down and hopefully you get it right. Till next time, take care guys.